Pointers is such a topic na that a lot of people find difficult to understand and try to run from it. Even myself, when the concepts of pointer came in, I simply quit programming, and here I am teaching the same thing. So I'll try the best way, the way I learned, the way I imagine a pointer to be. I'll try the best way. Now the languages which are made like Java, there is no concept of pointers in Java. In Python, people do not have to worry about pointers. They are made in such a way. But eventually what is happening now, like inside like packages which are handling these functions of pointers for you all without you know about that, they are eventually using the concepts of pointers we study in C++. So if I talk about a particular program in interviews, they ask about the pointers in the online assessment. Like output based questions are mostly based on pointers. If you are not, have you heard about the Josh Technologies company? I'm not sure about the name. It is a very good company, pays very good package, like 18 LPA now. Previously they used to pay like 10 LPA, but now they have increased the pay for 22 as well as the 23 batch to 18 LPA, which is a huge amount. And out of this, 11 LPA is base. So what this company do in their online assessment, though that company is purely Java based, they take the online assessment and give the questions of pointers using C and C++. And if you are not familiar with the concepts of pointers, you will be missing the 18 LPA. Coming back to the point, when we make a program or particular program is running, we say that the variables which are used in this program are stored in memory. RAM is the place which we consider to, not HDD or a SSD, because in those the files are stored. So let consider this is a structure of our RAM. That RAM is this, let's say 4 GB of RAM, but it is having a blocks of 1 byte. It is having a lot of 1 bytes blocks. This is how whenever we are storing a particular variable, it is getting stored in this particular memory block. Agree with me so far? So let's see, when we store a int variable, let's say we have stored a variable, I stand for int, and the name of the variable is, let's say, a. How many bytes it will be taking in the memory? So when the integer is stored, it is taking 4 bytes. This is how it is looking in a memory, that all these memory block an integer is taking, and it is storing a particular variable or a value inside it. So now suppose I have created a pointer p and I want to store the address of this particular integer. It will be storing the address to be as 1. When we see the declaration of special variable, that is a pointer variable, we always see that we always define that it would be of int type, int star or a char star or float star. You would always have seen that we always define the data type of a particular variable. The main reason why we do so is that to tell the compiler that this is not a normal variable, this is a special variable which is a pointer variable, and it will be storing the address of another variable or a memory block. And by defining a data type, since this pointer of is of int type, right, and it is holding 1 as an address. Now when I define it to be of int type, now the compiler will be having the idea that okay, I have to go at the memory block which is having the address as 1, and I have to read 4 bytes because it is storing an address of a integer variable. Let me also code it and draw. Let's say I made a variable a and stored a value 10 in it, and now I made a special variable pointer named as p and stored the address of a. And I believe everyone is clear with this ampersand sign, that what this ampersand sign do. When I did this, I occupied a memory block of 4 bytes in a memory and stored a value 10 in it. Name of this memory block is a, and let's say the address of this particular memory block is hash. I'm just taking the address in such a way that it will make easy for us, but in general they are hexadecimal numbers, so don't think that hash is the actual address of a memory location. So now when I defined a particular variable, a special variable, a pointer, it also takes a particular byte in the memory and stores the address. Though it is a special variable, but it is a variable, so it will be holding a particular memory in our RAM. So let's guess the outputs, then I believe we can move forward. What if I did this? Now what it will print? It's gonna print the same address, if I am right or not. So you all can see it is printing the same address again, same hexadecimal number again, because we are asking the compiler to do so. Ampersand a means address of a, and what p is pointer which is storing the address of a. So simple. now I do something like this. What should be the answer? What if I do something like this? What will be the answer of these statements? The answer will be 10 and 10. Here is the concept of dereferencing which comes into the play, and you all can see 10 and 10. So the size of pointer variable is very CPU specific, we can say. It can vary from different CPU to different CPU. In general, we can think it of as 4 byte, or some think it of as 1 byte, but it is very compiler and the CPU specific. Let's just figure out the size of 8. In my CPU it is showing 8. That means it is taking 8 bytes in my CPU, but in some other CPU it may take 4 bytes. Totally depends on different CPU to CPU.